I've just machined all four sides down to about 19.6. Just cutting the slot now for the bearing to fit in. Just got an 8mm carbide end mill in there, so we'll slowly take that down at 2mm increments down to about 24mm. I'll deburr that and set that up the other side. Let's make sure that bearing's going to fit. Yep. So we'll set that up the other way and we'll drill and ream to 10mm and we're going to make up a pin and Loctite that in. Alright, we'll just drill that out to 9.5. Hopefully it'll oversize a little bit so we can get this 10mm reamer down and see how it goes. Alright, done. We'll make up the pin. I'll set that up on my sand disc and we'll give that a radius around and we'll put it together. We've slotted, drilled and reamed. Just put a little radius around that to make it look nice. I guess doesn't serve anything in particular. Just using the Loctite primer just to prime the pin. I've already done the bore holes there. So put a bit of the 680 Loctite with the bore here, just a tiny little bit. Don't need much. There you go. We'll pop our bearing into place. Our pin. Give it a little tap. Through he goes. And we'll let the Loctite do that thing, and there we go. I've got my little face squaring tool done. So must have been one of my fastest tool builds. I did that in just a tad over 40 minutes, I think it was. So I'll let that Loctite go off over the next 15-20 minutes. Alright guys, we're back again. It's the next day after work, and surprise surprise, it's still raining. Now I'm just going to machine up these little collars, but we'll give this little face squaring tool a bit of a go. I've just mounted in there. I've never used one of these before, so let's see how we go. Look at that. That is the bee's knees. Alright, I'll nip that up and just have a look at that again. Yeah, that's spot on. So I'm going to face that off, just bore that out to a nominal diameter that we're also going to bore those side plates out to. So I'll get to and do these two smaller ones, and I'll do the bigger one, and we'll keep moving on. Now, we're going to take this out to 16 millimeters thick, and 16.5, so about half a mil. Right, I've machined and faced off these two. I'm not going to touch the board. Believe it or not, I had a 30mm drill that cut spot on 30mm, so I'm just going to leave those, and we'll do the bores with the side plates at 30mm so that we can match position these two. So this one here is the ring that we're going to machine off on the back. So it's going to get finished machined after the weldment's completed. So at the moment that's measuring about 14mm, so I'll take roughly half a mil off, it doesn't matter. Not a critical dimension at this stage here, just got to allow some machining. Really nicely. Really nicely, I'll leave it at that. So we've just got over 3mm on the machining allowance on this, so it'll be fine. What I think we might do now is we'll head off to the marking out plate, my gnarly marking out plate, and mark the positions for these bores, and get those plates done. Righty guys, I've marked this plate out. If we go to the unit, just on this section BB, the rear face is going to be our datum face for setting these plates up. So 34.5 in from one edge, and coming up we have to allow our 1mm machining allowance that we've got there, so that's 32.75, so 33.75 up. So on this unit here we've come across 34.5 and 33.75 up. So I've just marked that as a comfort dimension. I'll use the edge finder, get the edge of this, and then we'll drill it out to 30mm as a reference to be able to weld those bosses on. So sometimes on very large weldments, very large structures, we'll often do a separate drawing for the fabrication rather than have to add and subtract numbers as we have on this as a final machined item. So that's something we do, and sometimes if we're doing pre-machining work, depending on the job, once again we'll do a pre-machining dimensional set for that as well, particularly if it's going to have stress relieving. It might be a mandrel 3 meters long, 3.5 meters long. It's half a meter in diameter. There's a lot of machining operations in that. We need to stress relieve it, or we need to bring the properties back once they've been machined out, because your 4140s, your N26s are only good down to a certain depth. After that depth they're no better than a 1045 steel, so you need to reheat treat to bring those properties back, and I call that a birthday heat treat. So you know, when we're designing, you'll look at how that's going to be fabricated, what's going to be easiest for the machinist to understand, and what operation or what steps do you think he's going to follow. And often that's a two-way street. Sometimes you'll go into your fabrication shop and you'll talk to them about how they'd like to see it set up, if they want any little changes to the drawing to make it easier for them, and do the updates if they're the winning bidder on a job. So different ways we dimension to make things easier as we go along. Just horses for courses, basically. All right, let's go ahead and we'll get this zeroed up. I run at about 1000 RPM when I'm doing my edge finding. 2mm, which is half hour. Edge finder, and we'll come up to 2mm. Close enough to. I'll do us. Alright, so we'll come up 34.5. Lock it in place. And we'll come across. Sorry. 33.75. What am I doing? Now I'll come across 34.5. Alright. I'll set up, I'll do the pilot holes on this, and we'll come back with the 30mm drill. Alright guys, pilot drilled that. Going to go through this 30mm diameter drill and open that up. As we said, as a reference diameter to be able to get those bosses mounted to, so that we can weld them in place. I've got the two plates stacked together the way I've set this up, and you'll always end up with some little tiny variations in the width, and you'll have one plate that locks up and the other one that's going to start slipping. But Joe Poetsky, and if anyone's ever watched his YouTube channel, you'll know he's an absolutely wealth of information, and it's really, really good, solid, practical tips that he comes up with. So, and I'd never done this before, but a little bit of cardboard off one of the cornflake packets in between, sandwiched between the plates and the jaw, the moving jaw, takes up any slight little mismatch, and they lock up really hard. And I've used this a number of times, and that's a ripper little idea. And if you ever look at some of his work holding methodologies, absolutely brilliant. You'll learn so much from a guy like that. Here's me, who's got 200 subscribers, and he's probably running up around about the 50,000. But anyway, great tips. Certainly enjoy watching his videos. I certainly learn an awful lot. Right, well, I'll drop this in the back gear. And to run it in reverse. And pump the speed up just a tad. See what damage we can do. This will certainly test the cardboard theory anyway. Well, that was absolutely rock solid. Absolutely rock solid. Didn't even look like it was going to move. So, yeah, great little tip. Great little tip. All right, I'll get them out. We'll deburr those. The next job we're going to set up with is the 25mm plate. I'll mark that out, and we'll get that set up popped, and we'll get that set up in the forge or in the lathe, and we'll start doing some pre-boring on that one there. Righto, we'll get this ready to bore it out. I picked this little tip off of a guy called John Mills. You've probably heard of his YouTube video. I think it's called Double Boost, and I saw this the way he centered up a block using a dead center up against the center into the center pop mark, and it gives that elongation you can see there, and it gives you a good indication as to where you've got to tighten or loosen your jaws. And I thought it was absolutely brilliant little idea. So simple and so visual. He calls himself a mechanic who just stuffs about, but I tell you what, he's got some great little tips on his channel. This is just one of them. So there's some really good stuff out there on those YouTube channels that you know, people give up those little tips and tricks that make it so much easier for the rest of us. You'll probably see how bad I am at setting up a 4-jaw chuck. For what this is, that's within 0.01. So I'll just make sure that's back against the face, and we'll set up for some boring. So it's times like these, sometimes it would be good to have a bigger lathe, but we'll work with what we've got. So I've got a Morse taper 3-step up to 4 with a 2-inch drill in here, and it's just a tad over 2 inches. So we'll take a lot of the material out with this, and then we'll go ahead and bore it out to around about the finished size. Yeah, minimum size is 100mm for that lip seal to butt up against, so we'll take this out to about 90mm, and that'll give us our machining allowance. So we'll see how we go. Hold on to your seats. CRC left in here. Keep knocking the camera stand. Alright, that went through quite well. So it's given us a start, so I'll set up to start boring this out. I'm going to go inside now. I've had a long day, 5:30 start, and it's getting absolutely freezing out here now, so I'm going to pack it in for the night. We'll come back tomorrow night and we'll bore that out to size. One thing I did forget to mention is that I've got a couple of center pop marks there. They tell me that that's the base or the bottom of this plate. When centers are so close, it's so easy to make a stuff up when you're trying to assemble this to do the weldment. Just as a little heads up, a little visual thing, those little spots there let me know that that is the bottom, and hopefully I don't get it upside down. The side plates, it's fairly obvious where they sit because the holes are so offset, but when it's close to the centre, always a good idea just to center pop so you know where they're going to be going when you're finished. Alright, as I said, I'll pack it in tonight and go inside and have some tea and warm up. Alright guys, see you next time. Alright, we're back again. Surprise, surprise, it's not raining. Right, we're going to start boring this out. We're going to bring this out to around about 90-95 mil. We'll take the bulk of this off in the lathe before we weld it into place. So we'll make a start on that. I'm going to have to move this camera stand because it's being smack in the way of my on-off handle. What am I doing? Oh, let's try that. Better? Alright. Put in the gear might help. Let's put it into gear. Have to be careful when I come through. No, I'll miss the jaws. I don't end up packing into the jaws. Righto, we're nearly at the size. Hasn't taken that long. See what those chips are hot. When I was working many years ago, I had an old Gladstone bag I used to take to work, and I always had a tube of butazine picrate, which is a burnt cream, and a bottle of iodine in my old Gladstone bag. I'm going to bring this out to 90 mil. I've got about 2 mil left to go, roughly 90. Remember I said something about not going through into the jaws? What are we at? Yeah, just touching that jaw there. What a pain, we've taken a nick out of that too. Alright. I'm just a tad over 90, I'll just clean that up. Yes, there's nothing worse than getting one of those really hot chips stuck on your lip. Very uncomfortable. It's uncomfortable for a good week afterwards too. Alright, so that's that done. I'll get that out. So what sort of damage we've done to that jaw. That's not too bad. Just a little bit off it. Alright. Alright, we'll move on to the next step. Click soon.